Hello, and welcome to modeling learning assignment number 5. So, I'm going to start this off by pulling up a website. Now, you can develop all of your own SolidWorks, CAD files, all of those. But there are a lot of communities where individuals will share part files, assembly files, things that they've developed so that other people can use them. GrabCAD is one of those sharing forums. So if you go into the community, there's something called a library here, GrabCAD Library, and this will allow you to download SolidWorks pieces. Now, just looking at the page of what's available, I mean, look, somebody built an excavator and decided to share it. For some people, here they built the quadruped robot. This is something that has a step file or an IGES file that could be printed. It does have this rendering, which makes it look nice. They use SolidWorks Visualize to do that. Here's a table saw lift mechanism. I mean, there's just tons and tons of different types of content. As it says up here, there's over 5 million free CAD files. Some of them are absolutely worthless. But there's some that, I mean, you can find just about anything. Here, like, let's say, instead of looking for a manifold, let's say I'm looking for a motor design. Okay, you can actually find several different. Here's an Outlander motor, rear motor design. This is an STL file, which means it could be printed on a 3D printer or inserted into a drawing. It's not exactly a SolidWorks file. Here you could look specifically for SolidWorks, which would allow you to only review files that could be put into a SolidWorks system. Like, here's a disc grinder. I'm not really sure why that shows up in motor. Here's a Hobby King D5035 motor. Here's a constant speed motor. It's probably built off of a different motor model. There's tons of different items. Here, look at this motor. It looks like it's maybe at least 4 parts, offset, potentially a geared motor on the inside. You can keep looking at pages. You can actually find these files and you can use them into your drawings. Now, just out of curiosity, we could also go on here and look and see if there are any vacuums that are available. Here's a vacuum cleaner that somebody designed. Here's a pressurized vessel tank. That's not really a vacuum cleaner. I'm not sure why it would have a vacuum in there, but there's a vacuum oven. These are parts for a vacuum system. Here's a vacuum tank. So I mean, you may, oh look, there's a vacuum cleaner. Somebody designed a full thing. This is very similar to what it is that we're making. Even rendered a view, which is awesome because this is done in SolidWorks Visualize. It's a very, very pretty way. If you have a SolidWorks file, you can take this and, oh, he only gave the assembly file. Better hope all of the parts are built into that, because otherwise you need all of the parts. I have opened a few assembly files here on GrabCAD only to find out that the parts were absent. So you just get a blank file, and that's kind of unfortunate. But you know what? Feel free to look at how other people design their vacuums. Steal parts. Don't hand in something that's available on GrabCAD, because that is something that I check. But there we go. So here, what we're going to be doing for modeling learning assignment number 5 is we're going to be looking specifically at a manifold. Now, manifolds are very complex devices. They route air from one place to sometimes multiple places. Sometimes they look funky like this. Sometimes they're just pretty straightforward in 4 outputs. Some companies just like to get really fancy with their manifolds, as you can see here. Whereas some people, you know, it's just, this is easy to machine. You might as well put that together. So the manifold that we're going to be using is, I did find it through GrabCAD. Let me see if I It's this one down here. I believe. No, it might be a different one. I don't really know anymore. Oh well. But I have it, and so what I'm going to do is I'm going to open it up real quick. I'll have to navigate to my manifold, pop it open. There may be some conversions. You don't always know what you're going to be getting when you download these parts. They don't always work in the inch-pound second system. Sometimes they work in the metric system. Sometimes they work in other systems. Oh, dang. It won't let me open the CAM files for this, which is fine. It doesn't bother me at all. Should still open the file. Yeah, just waiting. But so here's this part. Now this is in the millimeter gram second. I can easily just switch this back to inch per second. But this is my file, and what I'm going to be doing is I'm going to be taking this and I'm going to be detailing this part in a SolidWorks dimension, SolidWorks drawing. Doesn't matter that it's a future version file. I use 2018 because I'm old school. First thing I'm going to do, just like always, is I need to go find my template. For you, this is available on Canvas. For me, I have it in one of my folders already. I'm going to go ahead and bring in this part file. So I'll double click here, put it down, put a couple views down, and a projected view because I like doing that on the first page. I'll go ahead and hit enter to get out of it. Now there's a lot to unpack in this part. This part would warrant an entire set of drawings just by itself. So for me, that's exactly what we're going to be doing. Let me shut this so that I'm trying to spare my computer some memory. This would warrant a set of drawings just by itself because it is so complex. We're going to have to detail absolutely everything about this, and quite frankly, it's going to require a couple of tools that we haven't talked about to this point. And it's going to allow us to use some of these very interesting extra viewports and do some really fine revisions there. So let's go ahead and finish filling out the title block and just finish this page. So this will be the exhaust manifold overview. General overview of the manifold. I will hit yes. I'm going to throw my initials into the properties real quick. And hit OK. And I'm going to throw just overall dimensions to kind of detail what the overall length of this part is. This is in inches. We could change that to millimeters if I hadn't gone into the part and switched it. Here this would be showing up in millimeters, and I would need to, or yeah, in millimeters, and I would need to change that to millimeters down there. But yeah, I fixed it. I prefer working in inches. Very American. And what they say about Americans. we would never use the metric system even if it was better. And dang it, I refuse. So here I'm just giving overall widths so that somebody could look at, whoa, don't know why that occurred at a weird angle. So that somebody could look at this and actually get a bearing for overall sizes. Generally on the first page, you want to include some information so that anybody who would need some general information, like how tall is this, how wide is this, they can find that on the first page. It's always good practice to have that available immediately so that somebody looking at this could just grab your drawing and have that information available immediately. I'm going to kind of drag everything over here to crowd the left side because I'm freeing up a spot right here to include some notes. Because you know me, I always love notes. I'm going to drop a note right here, and this note is going to say from cast 1020 steel polished with I don't know, sandblasting. So basically just tell people, go in, find some more information. I'll hit escape. That's all I need. Now, on our assembly drawings, I usually like to put a part number on these. Because this is only one single part, I'm not going to need a part number here because we're only ever talking about one part. So we'll go ahead and jump to our next drawing. Now in our next drawing, once again, we're going to be inputting our same manifold. We're not changing that, but we are going to be changing what we show about it. So first things first is I'm going to include something that is called a detail view. Now what it does is, if you hover over a detail view, it says this adds a detail view to show a portion of a view, usually on a large scale. What this is going to allow us to do is zoom in on different portions, and we're going to basically break up this part into multiple pieces just by zooming in on it. So I'm going to add a detail view. What this is going to say is, please sketch a circle to continue your view creation, and then select what you want. So here I'm going to pick about this piece here, and that's going to be my circle. And you'll notice that here the circle I just drew pops out. It's a much bigger circle. That's what doing a detailed view does. And what we can do here is we can actually set a custom scale to make this bigger. So here I actually kind of want to go 1:1 detail view. Now that causes this caption to move way down. So get up here, you hooligan. You'll also notice that up here, a label of A has been put right next to that circle we just drew. That specifies that this is detail view A, and here this says it's detail A. Here's the scale. Okay. Now what we can do is we can talk specifically about this piece. We can give some dimensions. We can really kind of hash out this design right here. Now this isn't really all that easy to see. If I go back to my drawing over here, there's kind of an inlet section, there's an outlet section, there's like a crosshairs things in there. Looks like the air comes in, and maybe there's a bolt connection right here. This is access to that bolt. It's just kind of gross. So what we may want to do is we may want to go into sheet 2, if it ever shows up. Okay, I'm just going to click down here, I guess. Forgot, that's how you're supposed to actually do it. If I click on this view, and I set this to have the hidden lines visible, problem is that the whole drawing gets a little bit more gross. So I don't actually want to set my hidden lines visible there. If I go down here into my detailed view, and I click on this, and I set this as show hidden lines, it's even kind of gross here. So I don't really like that. I'm going to leave this be so that we're just looking at the front face. Now, something else that I want to do is I want to create a detailed view of this, but I want it to be from an isometric view. So here, if I take this and I just click projected view from it, it tells me I can't do anything more with it. I can do a projected view from here. So you'll notice this allows me to produce that same projected view I had on the top page. So you know what? I'm actually going to create this projected view. Hit escape. And I'm going to create a detail view of this section view. Because it's going to better allow me to showcase what's going on over here. Okay, now you'll notice that this is called B. I'm actually just going to delete, because quite frankly I don't want this to look like anything other than detail A. I think the way that I delete this is I just hit the delete button. Yeah, and it just deletes the header off of there. Now I'll go in here and I'm going to use this at a 1:1 scale as well. Here I am going to shade this, and then I'm going to move this so that it's kind of in the corner. So to me, this is a little bit easier to look at than just simply having the component by itself. Now all of these are to scale. The beauty of this is if I were to show this in 3 views, I would be able to take out a ruler and actually measure this. Usually what happens in a real system is that somebody would use a program like it's called eDrawings. They would be able to go in here and they would actually be able to take measurements from this drawing without having to access the original SolidWorks file. That was created specifically to try to protect intellectual property so that you could share these drawings with someone. They could take measurements from them, but they would not be able to actually see what it was that you used to create these files, or they wouldn't have access to the components of the file, so they wouldn't be able to take that. So realistically speaking, you could have somebody come in here, measure this, be able to take measurements from it, and that's fine, and that's probably what would be warranted in a piece like this. But as for now, I'm just showing off some detail views. So we'll throw some dimensions on here. I'm going to dimension the width of these little platforms. Again, just kind of giving overall dimensions. These two. I'm going to get it lined up. And then I'll throw a third one here in between this. And I'll get it lined up as well. So there we go. Now I have my 3 dimensions here. It's going to be difficult for me to dimension that distance, all of these little tiny details. But providing this detail view with a scale at 1:1 does allow me to basically tell people, hey, if you need to go measure this to find something else inside of this, please feel free to do that. So what I'm going to take now is I want to keep what I have up here, but I want to change everything else that I have. So I'm actually going to take this and I'm going to copy this sheet and I should be able to paste. Oh, I'm supposed to be able to copy and yeah, dang. I'm supposed to be able to copy and paste these so you can get multiple drawings that just use the same thing. Why isn't it just allowing me to paste? It's weird. Why would it allow you to copy it but not paste it? So here, I guess what I'll do is the two drawings that I want the most are these two. So I'm going to click and select both of these two by showing up here and then dragging down to the left. Selects both of them. I'll hit Control C. Move over here. I'll hit Control V. Oh, it won't let me. I don't know how to duplicate this. Interesting. Interesting. This will let me copy it up here, but it won't let me paste it. Oh well. If I try hitting paste down here. Nope, still won't. Nope. Sorry I tried. Oh. Dang, well that's unfortunate. There is a way of duplicating sheets. I don't actually remember how though. Edit. I don't remember how to duplicate a sheet, but there's a way to duplicate sheets. We just won't do that apparently. So I'm going to go back to sheet 3. I'm going to put in my two drawings again. Well, here I'll put in my model view over the top. I'll go up here, and then I will put a projected view up here again, and hit escape to quit out of that. Now I'm going to put another detail view, and I'm going to detail this face down here, just because apparently I think that this one is important or something. So here, I'm going to change my custom scale to 1:1. Move it up so it's a little bit more visible. Move up the descriptor on there so it's a little bit more visible. And then just like the last one, I am also going to do a detail view here. That might be a little too big. I may need to shrink that. Set this to 1:1. Oh yeah, way too big. So here I can actually go back and I think I can click on this circle and shrink it. Yep, so I clicked on the outside of the circle and I am able to shrink it. I click on the center point of the circle and I can move it. So I'm going to try to going to move the whole part. Huh, that's interesting. Oh well, I'll accept that. I don't want this to be called D. So I'm going to click on this, delete this, zoom out, and delete this as well. Okay, so there we go. I have my 1-to-1 ratio. I'm going to change this circle here from being C. You'll notice the C isn't really even showing up. I'm going to change this to B. I'll move my B down. You'll notice the B automatically updates down here. So this just allows you to get a closer view of anything. That's what a detail view does. So in a full drawing, if we were to do a full drawing of this, you would have to do detailed views of all of these. And you'd probably have to show some dimensions. So this would be detail of middle inlet. Here this shows the middle inlet entry point. Because this has its own scale, the sheet scale only pertains to the small drawing there. The rest of that information automatically updates. I don't think I said a sheet. No, I didn't set a name out down here. So guess what we're doing now? There we go. And again, everything else already updates. So now we'll go into sheet 4. We've done a couple of detailed views. You'd probably want to continue on with those detailed views to give in-depth view of every one of those pieces. We're not going to keep doing that because it's basically just doing the same thing over and over again. Instead, what we will do is we will put down a model view. And I'm going to put the model view down at this bottom right corner. And I have a method to my madness. So just follow along here. This face right here is not perpendicular to here. So if I were to just bring out a projected view, this projected view shows this circle, but it's not a perfect circle. It's actually closer to an oval because this isn't directly perpendicular to that face. So if I go to try to measure the diameter of this circle, so here, smart dimension, this circle, it's going to give me something called a true measurement, which means it's not going to be able to appear, because this is a projected face, because it's at an angle, it's not actually 0.94 inches. It's actually, if you took a ruler and measured this, it might be closer to 0.8 inches. And that is unfortunate because that means that for these projected faces, it's impossible to get a real measurement here. So I'm going to delete this projected view. And we're going to do something very interesting here. That's called an auxiliary view. Now an auxiliary view allows us to project directly off of a face or an edge, something so that we could see a true dimension of this. Now here I want to, this says select a reference edge. I want to select this reference edge. Okay. So what you'll see is this is now labeled as view E. I'm going to go back and change this to C because we don't have a C yet. I'm going to move this marker. This arrow just indicates that that is the direction that C is looking. Come on, bro. Let me move C. Well, I guess C has to stay there. But this is view C now. So we can move this up a little bit. They will move together. But now I can actually see that this is a full circle. This is projected directly off of this view. So none of the rest of my dimensions are going to make any sense. But when I go to dimension this circle now, you'll notice it doesn't give me the true measurement because that's actually the real diameter. I don't have to try to get a true measurement. I can actually measure a real diameter by putting it there. So I can measure inside, outside, and somebody could take measurements from this drawing if they wanted to. Come on, allow me to select this line. No, it doesn't want me to. Keeps telling me no. Yep, keeps telling me no. So we'll just keep it as the inner diameter. I'll let it escape. Okay, so here, what I want to do quickly is I want to specify the angle between this line and what would be the horizontal. So here I have a horizontal line up here. This is flat. If I click the flat line and then I click this line, it's not really going to let me select and come up with an angle. And a lot of that is because these are curved. So if I click here, it's also going to tell me it can't come up with a dimension. Which is great. Super helpful, SolidWorks. So when I click on view C here, is there any options here that will let me see? Nope. But I could change the scale. I could use the custom scale 1:1, 1:2. Really blow it up. You'll notice anytime you change the scale, it immediately goes down here and says, this is your new scale. Let's see if I can't, move my arrow so that it's pointing at the face that it's coming off of. So there we go. We'll just leave it that. We'll say circular projection. Or just circular outlet details. And then in the description, this is a projection of the circular outlet at top of manifold. Okay, and all the rest of my details are already there, which is nice. Okay, so that was the auxiliary view. The whole purpose of having an auxiliary view is it allows you to take measurements in an actual face that is perpendicular rather than having to see an oval and then just say, well, you just got to trust me on this. It's actually this dimension, even though it doesn't show up like that. Okay, so that's the purpose of the auxiliary view. Now there's something else that we have, and it's called a section view. So I'm going to jump into a new tab, put down another one of these items, because why not? And what I'm going to do is I am going to not put down another projected view, but I'm going to put down a section view of this drawing. Now if I cut a section view out of this, it'll allow me to see inside of this component. So here, if I drag this down, this is what the bottom view looks like if we were to cut across that line and look straight up. Okay, you can see these hatched lines are where it gets cut, and the rest of it is just, well, regular material. That's where the manifold comes together. Yeah, but that's what we can do. And if we drag this line. We can change where it gets cut. Let's see if SolidWorks doesn't die on me right now. And a better computer that isn't trying to run Streamlabs and SolidWorks. You should be able to move this line. But not just the arrow. Oh well. I'm going to click on this, change this to D. And notice it says section D to D. Now I can take measurements of the inside of this, etc. So I'm just going to take a couple of section views here. Here I'm going to create one more projected view so I can see the side view. And then I will take a section view going straight downward. So I'll hit escape to get out of the projected view. We'll do another section view. Here it wants to do one up and down. I don't want to do one up and down. I want to do one vertically. So that's what I'm going to do. You can specify a point on that vertical line. You can specify an angle, an auxiliary, which is, like I said, it's parallel to a face. So here we could cut parallel to this face. Here this one is an aligned, which would allow us to align with another axis or something. So here this wants me to just pick yes. I'm going to go back and change that away from G. But now I can see the inside of what this actually looks like. So that's kind of fun. Change just to E. And there we go. Now you can see this is where all the section that gets cut. The open spaces are the areas where there is no cuts. And that's everything that it sees looking that direction. Now if you wanted to switch views, you can actually switch this to the other side. Oh, that's not the way of doing it. Okay. You can do that. I believe you have to switch direction. There's a button. Flip direction. And then what it'll do is it'll show you what the back side of it looks like. Okay. So that's another option that comes with section views. So here section views allow you to see the interior of a part. If you have very complicated interior design pieces, or even if you have screw holes that come to a point or something, it might be nice to have a section view so that you can specifically show those screw holes. You can focus on those screw holes without having to see the rest of the component, really. So that is the purpose of a section view. Now there are a few other views that are available. There's something called crop view that allow you to basically just zoom in on a very specific piece. There's a break view. If you have a really long part, you can put in a break view that basically says we're going to ignore this section of the part and we'll be able to take dimensions across the entire length of it. Broken out section, this is very similar to a section view and mixed with a detailed view. So it allows you to zoom in and cut out a piece. That does happen. It's not nearly as common. But those are some of the different types of views that we have available to us when it comes to doing drawings. So here, oh, excuse me. I'm going to quickly change this name of drawing. I'm going to call this detailed. No. I don't actually know if that's typing anything. There it is. Yeah, I was typing. It just didn't want to register. This computer dies. Side view. There it is. So we'll change the description. And this will be manifold interior. Okay, so spelled that wrong. I don't know why. my SolidWorks is being weird. But you know what? It's whatever. I don't care enough. Here we go. Now we have 5 pages where we start with a full view. We give the full dimensions. And then on subsequent pages, we zoom in on specific pieces of interest for our drawing. And once we've... Oh. Not bad. I don't know why I included that piece. Huh. I wonder how I move that detailed view. Huh. I may just need to... Excuse me. Delete it and put it down again. That didn't come out any of the way that I wanted it to. So, there we go. That's better. Makes a little bit more sense. Set this 1 to 1. Set it shaded. Move it into position. And delete the detail. So there we go. I've got 1 sheet that's the general overview, 2 sheets that are details. You'd probably have a lot more sheets that are details if you did this for a real environment. 1 sheet that shows the auxiliary view of the end, and then 1 sheet that shows section views. And you would definitely have more section views. You would probably use those broken out sections so that you could focus on individual pieces because this part is so complex. But we're just doing a simple project here, so I'm going to go ahead and end the video there. We will go in here and we will print. I'm going to use a different PDF printer. I'm going to use Microsoft Print PDF just to kind of showcase how it's different here. I'll hit OK. And I have no idea what this is going to print. It may only print this 1 sheet. In fact, I think it will. Instead of, could not start, I'm going to go ahead and, before I do that, select all of my sheets that I want to print. And then hit File, Print. You could publish e-drawings, you saw that option. Here, this is going to be all sheets. Oh, it should have just done all sheets no matter what, I guess. We'll try that. Print, all sheets, Microsoft Print Page. Otherwise, you could just do the current sheet. And we'll put this in here as MLA 5. And there it's spooling through all 5 of the pages. So that is modeling learning assignment.